duality, an indirect utility function, and expenditure function. So what do you mean by duality? Guys, if you look at it, this is our x, this is our y, and this is the budget constraint. Clear? Our budget constraint is given to us. And then we ask ourselves a question. What is the maximum utility I can achieve given this budget constraint? Is this the maximum utility? You not? No. You can go still further. Is this the maximum utility? No. You can go still further. Is this the maximum utility? Definitely. Okay. This is the maximum utility. So given the budget constraint, you maximize the utility. Okay. So given the budget constraint, you maximize the utility. Clear? And this is called utility maximization problem. This is called utility maximization problem. Now you look at the same problem with a different angle. Right. Now you are given with the utility U naught. For example, U2, since U2 is maximizing it here. And then you ask yourselves, what is the minimum expenditure you can achieve? Is this the minimum expenditure? No. You can go still lower. Is this the minimum expenditure? No. You can go still lower. This is the minimum expenditure, right? So at this point, you are minimizing expenditure. So what you are doing here, given utility, minimize the expenditure. So given the utility, you minimize the expenditure, and this is called expenditure minimization problem. This is called expenditure minimization problem. And what you do in this is basically, and this is called a dual problem. That is, answers to the utility max and the expenditure min will be same under certain conditions. And this is called a dual problem. So what you do is, here what you do is that you maximize Ux subject to Px equals to M. What you do here is you minimize Px subject to Ux equals to U bar. So guys, this is the dual problem, that utility maximization implies expenditure minimization and expenditure minimization implies utility maximization. Okay, so this is problem A and this is problem B, and we are assuming something. We are assuming that local norm situation is satisfied. Utility function is continuous, right? And answers to both problems exist. Right. So answers to both problems exist. So these are the three assumptions which we are making. That local non-citation is satisfied, utility function is continuous, and answers to both problems exist. Now let's prove the first part, that utility maximization